Okay, so today what we're going to do is we're going to continue to look at section 8.1. This will be section 8.1, day 2. And now we're going to look again at the addition and subtraction formulas. But today we're going to look at the tangent ones, and then we'll see some of the applications of these formulas. So what we're going to start by looking at today is the tangent addition and subtraction formulas. So for tangent, the addition formula is tangent of our angle S plus some other angle T is equal to tangent of the first angle plus tangent of the second angle divided by 1 minus tangent of the first angle times tangent of the second angle. So look at the structure of that. Notice that the plus on top matches the plus inside the original parentheses, and notice the minus on the bottom is opposite of whatever sign you used on the top. So that's going to be the key structure to the tangent of S minus T formula, which is then going to be tangent of the first angle minus tangent of the second angle over 1 plus tangent of the first angle times tangent of the second angle. So these are your addition and subtraction formulas for tangent. So obviously if S is pi over 3 and T is pi over 4, you guys can go ahead and you can evaluate this. You'll have some complex fractions involved. We've talked many times about how to simplify those. I'm not going to go through that in these particular notes, but you could just be careful and simplify those out without too much trouble. What I do want to talk to you about is I do want to talk to you about this problem where they ask you to simplify, and then they give you tan pi over 9 plus tangent 2 pi over 9 divided by 1 minus tangent pi over 9 times tangent 2 pi over 9. Notice that 2 pi over 9 and 1 pi over 9 are not unit circle angles that we have memorized. But notice that the structure of this matches the structure of our tangent S plus T formula. So therefore, this must be our S and this must be our T. So this is really just equal to tangent of S plus T. That then simplifies down. We already have a common denominator. That becomes tangent of 3 pi over 9, which is really tangent of pi over 3. Notice we now have a unit circle value that we know. So if we take a look at the unit circle and we take a look at pi over 3, which is up here, which has coordinates 1/2 comma rad 3 over 2, notice that tangent is going to be y divided by x, which is going to be rad 3 over 2 times 2 over 1, the reciprocal. And so it turns out that this big giant mess is really just simplifying down to the square root of 3. So that's an application of our tangent addition formula. Okay, I just have a couple of other quick examples that I want to run through with you on today's video. I'm trying to keep it down to a small amount so that you can go back and watch it again if you need to and take a look at some of the problems hopefully tonight as well. Let's now take a look at a problem like this. What if they tell us that sine of S is equal to 3 over 5, where S is between 0 and pi over 2, so therefore we're in quadrant 1. And they tell us that sine of T is equal to negative square root of 3 over 4, where T is between pi and 3 pi over 2. In other words, quadrant 3. So the idea here, we've done this before where we draw the picture, just this time we're going to have two pictures to draw. We're going to have one picture for the S triangle and one picture for the T triangle. So notice when I go over here to quadrant 1 and draw my triangle, I get something that looks like this. When I go to quadrant 3 and draw my triangle, I get something that looks like this. Here is my angle S with my right angle. Here is my angle T with my right angle. So We know that sine is opposite over hypotenuse. So opposite is 3, hypotenuse is 5. We're going to use the quadratic formula. A squared plus 3 squared equals 5 squared. So a squared is equal to 25 minus 9 is 16. So a is equal to plus or minus 4. In quadrant 1, though, this needs to be 4, positive, because x is positive in quadrant 1. We do the same thing in the t picture. We know that sine is opposite over hypotenuse. We know the opposite's the one that has to get the negative because the hypotenuse is always just a length, so it's positive. So again, a squared plus negative rad 3 squared equals 4 squared. That's a squared plus 3 equals 16. So a squared equals 13. That makes a equal to plus or minus the square root of 13. So here's the square root of 13, and because we're in quadrant 3 and this is our x, it must be negative. So hopefully you followed along that. It's just doing what we've done in previous chapters. We're just doing it with two separate pictures in the same problem. One for s, one for t. Now, here's the key to doing this. They asked us to find, they haven't asked us to find anything yet. What they want us to find is they want us to find sine of s minus t. Well, the problem is we don't know what s is, we don't know what t is, so we have no way of evaluating this directly, so we have to evaluate it indirectly from the pictures. And so what we're going to do is we're going to expand this. And so we know that sine of s minus t is really sine of s cosine of t minus cosine of s sine of t. And these values, although they are not coming from the unit circle values that we know, they are going to come from our two pictures. And so sine of s we know is opposite over hypotenuse in the sine on the s picture, 3 over 5. Cosine of t is adjacent over hypotenuse, so negative rad 13 over 4 from the t picture. Cosine of s, go back to the s picture, cosine is adjacent over hypotenuse, 4 over 5. Sine of t is opposite over hypotenuse, negative rad 3 over 4. So again, that came from the t picture. So now we're going to multiply across and we get negative 3 square root of 13 over 20 plus, because we have negative times negative, 4 square root of 3 over 20. We already have a common denominator, so this becomes negative 3 square root of 13 plus 4 square root of 3 over 20. This is the value of sine of s minus t in this case. So that's the way those work. You're going to have a different picture for each of the angles that are involved. Draw the picture with the triangle, make sure you put it in the proper quadrant, use the Pythagorean theorem to fill in the missing sides, and then you expand and go from there. Okay, I just have one last example that I want to point out to you today. We'll keep this nice and short again. And that is, what if we are given that tangent of s is equal to 2 and tangent of t is equal to 3? And they want us to compute tangent of s minus t. Well, we know that we can expand this into tangent of s minus tangent of t over 1 plus tangent s times tangent t. Now, here's where people mess up. They see tangent s equals 2, they see tangent s, and so what do? They make it tangent of 2 and then tangent of 3. This is not okay, guys. Put a little tear on him. Why? Because that is saying that s is equal to 2 and t is equal to 3, but that's not what the original information said. It said that tangent of angle s is equal to 2. So what this should be is this should now be 2 taking the place of tangent of s, use parentheses because we're substituting, 3 taking the place of tangent t, over 1 plus 2 times 3. That's going to give us negative 1 over 1 plus 6, which is 7. This is the correct answer. So I wanted to show that to you so you can avoid that common mistake of actually substituting the 2 and the 3 in for s and t instead of the entire tangent value. Okay, so I think that'll be enough examples to get you going through most of the homework assignment. Again, we kept this nice and short today, right around 10 minutes, which is, I think, a good length, so that you can go back and rewatch things if you need to, and hopefully you will take it upon yourself to start taking a look at some of the problems from the homework assignment that you're going to be working on, or the classwork assignment that you're going to take a look at in class tomorrow.